This lesson is going to show you how to do different operations of functions. We're going to do operations such as addition, multiplication, subtraction, and division. Here's how we write how to add functions. When you see something like f plus g, what it's telling you is it wants you to add the two functions together. If you see multiplication, f times g, then they want you to multiply the two functions together. Same thing with subtraction, f minus g, and f over g would mean division. Okay. The domain is the possible values of x. The domain of functions is all real numbers. When combining functions, new functions' domains will be whatever they have in common, the intersection of domains. So when two functions with domains of all real numbers are combined, the new function has a domain of all real numbers. The only exception is division of functions because we can't divide by a zero. Okay, so let's talk about each of these different operations. We have two functions. F of x is equal to 3x minus 1. 3x minus 1 is the first function. G of x is equal to 2x plus 5. 2x plus 5 is the second function. Since this problem, the first part is a, f plus g of x, we are going to add the two functions together. The first function, f, is our 3x minus 1. That is being added to our second function, g, 2x plus 5. Notice that the symbol between the two functions is plus. It's kind of basically like plugging in. Now it's time to simplify. 3x plus 2x is 5x. Negative 1 plus 5 is positive 4. 5x plus 4 is our new function. Now let's try the subtraction one. In the subtraction one, again, f minus g, so f comes first, the 3x minus 1, and now the minus, g, 2x plus 5. The only thing you need to watch out for this is that you distribute that negative so that it's minus 2 and it's also minus 5 now. So our answer to this one, 3x minus 2x is x, and negative 1 minus 5 is negative 6. X minus 6 is our new function. F times g of x would mean you take the first function, f, 3x minus 1, and we're going to multiply this time. Multiply it by g, 2x plus 5. This is just FOILing. We've done lots of that this year. We end up with 6x squared, 13x, and negative 5. Now let's try f divided by g. F is on top, so 3x minus 1, on top of g, 2x plus 5. This is our final answer because I noticed there's no GCF on top or bottom. So reduce when you can, but do know that in this problem right now, there's no reducing, so we can't. Okay, but try to reduce when you see that you can. Let's try that with some different types of functions. This time we're going to do f plus g of x. F comes first. 2x plus 5 is going to get added to g, 3x cubed. Since none of these things are like terms, let's just make sure we put it in standard form. 3x cubed comes first, plus 2x plus 5. Now let's try the subtraction. 2x plus 5 minus the 3x cubed. Again, there are no like terms here, so let's make sure we write it in standard form. Minus 3x comes first. Now our positive 2x and our positive 5. The negative only affects what comes after it, and that's the 3x cubed. Now it's time to try to multiply f times g. This is a little bit of distribution. We end up with 6x to the 4th power plus 15x to the 3rd power. And now let's try to find our division. F divided by g. F divided by g. There's no GCF on the top, so I can't pull anything out to cancel out things in the bottom. So of course this is also our final answer. There's no reducing in this problem either. There's one other way that functions can be combined besides add, subtract, multiply, and divide. These are called composite functions. It's like putting a function inside of another function. The way that we read this part right here is we read it as f of g of x. So it's f of g of x. That's how I'm reading it. Because you would read it just as g of x or f of x. And since the g is inside of the f's parentheses and the x is inside of the g's parentheses, we say f of g of x. So let's try that. So the first problem, what they're saying, is they want you to take the g function and put it inside of the f function. So here is the f function. Instead of the x, I'm going to put parentheses. Now it's time to write our g. Our g function is 3x plus 2. Close it, and don't forget to put the square that was on the x in the f function. So notice, this x part right here has opened up and allowed all of the g to plug into it. We do want to simplify and work this out. This means 3x plus 2 times another 3x plus 2. Our final answer after FOIL and multiplication is 18x squared plus 24x plus 8. It is possible to put a function inside of itself. G of x means you want to put the g function into the x in the g function. So let's write down the g function. It starts with a 3, and then there's an x. That's where the plug-in happens, is the x. I'm going to plug in what into the x? Well, the g function. So you're going to plug it back in. And don't forget to end it with the 2. We do want to go ahead and simplify this. We end up with 9x plus 8. Let's try 2 more examples to make sure we see a good variety. So I want to do f of g of x. Plug the g into the f function. Our f function has a negative 2 exponent. Our g function is 3x to the 1 over 3. Since this has power to power, let's go ahead and multiply. Let's go ahead and multiply these exponents. What exponent is the negative 2 multiplying on the 3? She's multiplying the 1. We end up with 3 to the negative 2 and x to the negative 2 over 3. 1 over 3 times negative 2 is negative 2 over 3. We do want to make these negative exponents into positives. So let's put them over 1. 3 squared is now 9. And now our x has a 2 over 3. We're going to now change our fraction exponent into a root. And here is your final answer. Let's take a look at f of x. We are going to put the f function back into the x in the f into the f function. So I'm going to open up parentheses and put the -2. The parentheses are just like the x. What function are we going to put in here? It says I'm putting the f into the function. See? Putting the f of x function in there. And that's an x minus 2. Go ahead and multiply these. -2 times -2 is positive 4. So this would be our final answer for this one. Okay, as always, if you have any questions, leave a comment or email me. Otherwise, I'll see you back in class.